An accounting office has 6 incoming telephone lines. The probability distribution of the number of busy lines is as follows. Use the above probability distribution table to find the following. Well, first, we want to find the probability that x is between 4 and 5, including the 4 but excluding the 5. So if you've never seen this before, this is the way that we represent the concept between in mathematics. And the reason that we use this notation instead of saying the word between is because between doesn't necessarily tell you if you need to include the endpoints or not. So that's where these symbols here come into play. So if x must be greater than or equal to 4, that is inclusive. And if it's just less than 5, then that's exclusive. So it's a little bit more precise of a notation. Now, let's find out which events qualify. So if x must be greater than or equal to 4, and I know that that symbol looks like a less than or equal to, and I'm reading it as a greater than or equal to. And this is one of the perplexing things about inequalities, is that you have to read from the variable to the number. So it is read as x is greater than or equal to 4. So if it's greater than or equal to 4, it could be 4 or more, but then it also has to be less than 5. And if it's less than 5, well, then it really only leaves 4 itself. So this probability would be 0.15. In the next example, we want to find the probability that x is greater than or equal to 2. So we're greater than or equal to 2, so it could be 2 or more. But it also has to be less than 4. So if it's less than 4, then 2 or 3 are the only possibilities. So 0.15 and 0.42. Those add up to 0.57. The last question here wants to know the probability that x is less than 6. Well, if it's less than 6, then it could be any value that's possible in our sample space up to, but not including 6. So all of these probabilities here, we could add together, and that is going to be our probability. Now, if you'll notice, this last probability is 0, which means the sum of all of these probabilities together is 1, and if this one's 0, then it actually means that the sum of these probabilities is 1. So the sum of my highlighted ones in this case is equal to 1.